the last class that we had, we learned how to do hypothesis testing questions, right? So given a large, scary paragraph, we were able to work through it. We were able to find the p-value using the one sample z-test on Minitab, and you were able to figure out if you rejected or failed to reject the null hypothesis. Now, in these questions, you were actually given this thing called alpha. I call it the significance level. You don't have to know that, it's just alpha, right? And usually it's a number that's pretty small, like 0.05, 0.01, even 0.1, but it doesn't get any higher than that. It's usually a really small number. Now, I told you that the question just gives us alpha, but I didn't explain what it actually is. So that's kind of what I want to talk about for a little bit today. And before I talk about what alpha actually is, well, let me just remind you of something that you might see on your quiz today, okay? Remember, on your quiz, you have that chart that you're supposed to determine, or that you're supposed to use to determine what type of error you're made. On the top, it says HO true, if I can spell true. It says HO false, and that's what is happening in real life, right? And then the first column describes what decision we make. So if we reject the null hypothesis or if we fail to reject, right? Okay, now I don't expect you to memorize this chart, but let me just remind you what's on it. If you reject something that's true, then that's an error, right? And we call that a type 1 error. Okay, if you reject something that's false, well, you're rejecting something that's wrong. So that's definitely a correct decision. Okay, now on the other hand, if you fail to reject something that's true, you also made a correct decision. And if you fail to reject something that's false, that's also an error, but we called it a type 2 error. Okay, so we don't like errors. That's not very good. And an example of, well, how to use this chart is maybe our card example, right? Remember, I had a deck of cards. Our null hypothesis was that the cards were 50-50 red and black. We did an experiment and, well, we got a bunch of red cards, which made us really suspicious. So we rejected the null hypothesis, right? But we didn't actually know it was true in real life. So I flipped over the cards and they turned out to be all red cards. So in reality, the null hypothesis was false. So we actually did make a correct decision when we did that whole experiment. But what if I turned around the cards and they ended up being true? Or sorry, what if I turn around the cards and they ended up being 50-50? Then the null hypothesis would have been true, right? We rejected null hypothesis being true. That would be an example of making a type 1 error, okay? And we don't want to make a type 1 error. Type 1 error is an error, right? And we don't want to make the wrong decision. So we want to reduce the probability of making a type 1 error, okay? Now, what is the probability of making a type 1 error? Well, that's alpha, okay? Alpha is the probability that you make an error. Okay, that's basically the definition of what alpha is. Okay, so whenever you're given a problem and it gives you what alpha is, you're really actually given, well, we want to make sure that the probability of making a type 1 error is at least like 0.05 or 0.01, something like that. And that's why, like, when you look at these questions, alpha is always like a really small number, right? It's always 0.05 or maybe even 0.01. It could be like 0.1, but it never goes over 0.1, right? It's usually a very small number, okay? Which makes sense, right? We don't want to make a type 1 error. We want alpha to be really small, right? Well, that begs the question, why don't we make alpha like 0.00000000001, right? That would mean that we wouldn't make a type 1 error at all. Why don't we make that probability really, really small, okay? Well, the problem with that is if we lower the probability of a type 1 error, guess what? Oh my gosh, guess what probability goes up? Type 2 error, okay? So if the probability of a type 1 error goes up, the probability of a type 2 error, oh my gosh, I can't talk today. Probability of type 1 error goes down, probability of type 2 error goes up. So we don't want to make a type 2 error either, because that's also making the wrong decision. So we kind of have to play this balancing game of making the probability of a type 1 error pretty small, but not small enough so that the type 2 error gets really, really big, okay? So that's why in the questions, alpha is usually like 0.05, 0.01. It doesn't really get smaller than 0.01. It doesn't get much bigger than maybe 0.5, 0.1, probably not any higher than that. We're kind of playing this balancing game of the type 1 versus type 2, which is why we even learned about these errors in the first place. Okay. Any questions on like what alpha actually means? We're starting this new set of notes, section 9.3. Okay. I was going to say something, but I forgot. Oh yeah. By the way, for some reason, I cannot talk today. I am like tripping over my words, so I apologize for that today. I don't know what I'm doing today. Maybe it's because it's Friday. I don't know. Okay, let's just start this section, and I'm very sorry if I stumble over every single word that I try to say today. Okay, start a new section. We're starting section 9.3. We're still going to talk about hypothesis testing. So same sort of idea, but we're going to be working on questions that are slightly different than the questions that we saw on Wednesday or Monday. Okay, and to give you an idea of how these questions are different, let's go back to the idea of confidence intervals. So like what we did way back, maybe a week and a half ago. Okay. Remember, confidence interval questions can be a little bit different depending on if you use the small chart or if you use the big chart, right? Okay, so there's a small chart, there's a big chart. Does anyone remember like what's the difference between using the small chart and using the big chart? The standard deviation, right? So if you're given a question and you're trying to decide which chart to use, you take a look at the standard deviation. Okay. And it depends on if you're given the population or the sample one, right? Do you remember if you use the population or standard or population or sample for the small chart? Population. It's the population standard deviation. I know it's been a long time, but the population standard deviation or sigma is for the small chart. If you're given the sample standard deviation or S, you're using the big chart, okay? And I don't know if you kind of remember, the reason why we use these is because the small chart uses the normal distribution and the big chart uses the t distribution. Okay, that's kind of a random fact there, but it does kind of have to do with how we do these questions. Okay, so what we're going to do is the difference between these types of questions using hypothesis testing is the same thing. It's actually the same difference between these types of questions, and we use a different Minitab test based on which one that we're given, okay? So let me just kind of explain to you how this is gonna go, all right? Let me do this, okay? On the left, we have section 9.2. That's the old stuff that we did, okay? So what we did on Monday and Wednesday, that's section 9.2, okay? Section 9.3 is what we're doing today. So this is the new stuff, okay? Let me briefly go over what the old stuff is, and then we'll talk about how the new stuff is a little bit different. Okay, so the old stuff. So what we did on Wednesday and Monday, we're given a bunch of variables, okay? The first variable that you're probably given is mu, or the population mean, right? And it's not really what the population mean is, but it's like what someone thinks the population mean is. For example, we thought that the average number of red cards was 5, right? So that's the hypothesized population mean. We're also given the population standard deviation. Okay. Then we're introduced to a sample. Usually the sample size is n. Okay. We're also given the mean of that sample, or x bar. So sample mean. And the very last symbol that we're given is the probability of a type 1 error, or alpha, right? So alpha is the significance level. Okay, so based on all of this information, all these symbols, we're actually able to figure out what our hypothesis test is, do the p-value method to come up with that p-value and determine if we reject or fail to reject the null hypothesis. Okay, now one thing I didn't tell you is the way that we went about finding the p-value, it used the normal distribution. I don't think I even said that during class on Wednesday, but you do use the normal distribution to find the p-value, okay? And to find the p-value, I told you that you could learn the by hand method, and that's totally fine if you want to do that. But the easier way to find these p-values is to use Minitab. And in particular, you go to stat, basic statistics, and one sample z-test, right? That's the test that we use on Minitab. Okay, so that's kind of summarized what we did on Wednesday, the problems, what they give us, and the test that we use on Minitab. Okay, let me tell you how this section is going to be different. Okay, the new section that we're learning today is going to give us the population mean. Okay, but instead of the population standard deviation, going to give us S, the sample standard deviation. Okay, and guess what? Everything else is the same. We're given the sample size, the sample mean, even the significance level. Okay, the only thing that's different between the left problem and the right problem is we're given the sample standard deviation, not the population standard deviation. That's the only difference. Okay, now I think you know where I'm going from here. Instead of using the normal distribution, what distribution do you think I'm using? T distribution. And what's really useful about this is the test that we use on Minitab is the one sample t-test. So the way I used to memorize this is the normal distribution, usually z-scores have to do with the normal distribution. So that's why it's called the z-test. T-distribution, t-test. Not very creatively named here. Okay. Any questions on how these problems are going to be different? Okay. So if you understand the stuff from section 9.2, these questions are super easy because it's pretty much the same thing. You're just using a different test. So what I've done is I've kind of summarized everything up here. You don't need to actually memorize like all the steps if you don't want to. I think it's easier to kind of just follow through what Minitab asks you to do, but it's up here anyway. Step 1, stating your assumptions. Central limit theorem has to do with the p-value. I don't really explain how that goes on, but you do have to do the assumptions for it. Okay, that's definitely something you have to do. Okay, step 2, non-alternate hypotheses. Step 3, finding the confidence level. That's the same formula as the confidence level that we did in the last section. So if you memorize the formula for Wednesday, same formula for today. Okay. Step 4, Minitab. You use, oh my, was that a child? The one sample t-test instead of the one sample z-test. And basically everything else is the same. Step 5 and 6, deciding to reject or fail to reject, writing down our conclusion, same steps. It's literally just using a different test on Minitab. That's the only difference that we're doing here. Okay, why don't we do an actual example and see what happens? Okay, example 1, we are given a problem about FICO credit scores. I honestly don't know anything about credit scores except that you want a high one. So apparently it's talking about the mean credit scores that people have. Okay, so why don't we just read through this and just write down all the information that we're given. Scores range from 300 to 850. I don't think that tells us anything with a score of 720, blah, blah, blah. Okay, here we go. An economist wants to determine whether the mean FICO score is lower than 720. Okay, well, 720 is definitely a number there. It's talking about a mean. Do you think this is a population mean or a sample mean? You saw my face, you're like, population. Anyone want to kind of explain why it might be population? And? Yeah, right. So, okay, Angie's like, okay, there's only 2 options, population or sample, right? And then later on, it talks about the sample and it gives us that the sample mean is 703. So if we know the sample mean, then we can't have another one, right? So 720 has to be, by process of elimination, the population mean. Also, when we introduced 720, we weren't even talking about a sample, right? The sample wasn't even introduced in the first place. So you can't really have a sample mean if you don't have a sample yet, right? So here the sample mean is definitely going to be 720. Okay. All right, going on, we have a random sample of 100 people. Well, that sounds like a sample size to me. And it says these 100 people have a mean score of 703. As Ange said, that's got to be the sample mean. All right, X bar is 703 with a standard deviation of 92. Well, sample or population standard deviation? So I heard population and sample. Everyone's scared now because you all got the first one wrong. It's actually the sample standard deviation. Okay. If the standard deviation is mentioned in the same sentence as the as the sample mean, sample mean, standard deviation, it's going to be talking about the sample, right? It's also introduced right after we introduce what the sample was. So this is why I'm thinking sample standard deviation. Okay. So it says, can the economist conclude that the mean is less than 720? Use the alpha equals 0.05 level of significance. Cool. Okay. Well, why don't we just go through all the steps and figure out what to do, and I'll show you what to do on Minitab after that. Okay. Step 1, stating our assumptions. Okay. Now I didn't actually write out what the assumptions are on here. The first thing we have to do is figure out if we can even follow the process on the path on the last page, right? The process that we use for these questions really determines on if we're given the population versus the sample standard deviation, right? We're given the sample standard deviation, so it looks like we're good. These questions always use the sample standard deviation. So let me just write out that S is given to us. Okay, smiley face for that. Okay. The next one is going to be, is the sample size bigger than 30, right? That's what we've been doing for the past couple of weeks. We have to check to see if our sample size 100 is bigger than 30. Is 100 bigger than 30? Yeah, right. So looks like we're good. We don't have to do anything else. 100 is bigger than 30. Okay, cool. So that means we can actually do the problem. It's a child. I'm sorry. Oh, okay. Step 2 is stating our null and alternate hypotheses, right? So remember, on your quiz, I'm going to ask you to write the null and alternate hypotheses. Anyone remember the symbol for null hypothesis? H0, good. We always put a colon after it to say, okay, the null hypothesis is coming. We're always talking about mu, or the population mean, and we're always saying it's equal to something. What is mu equal to in this example? 720, right? This is why, honestly, I like writing the information up at the top, because I don't feel like going through the question and figuring out, okay, what's the population mean here, right? I think it's easier to just write it down in the beginning, and then, well, now you just have it when you're writing your null and alternate hypothesis. Okay. On the other hand, alternate is H1. We're talking about mu. We still use the same number. It never changes. What do you think? Less than, greater than, not equal to? Less than, right? My big hint is, if you're ever confused what symbol to use, take a look at the last sentence of the paragraph, or the second to last sentence of the paragraph. It usually asks the question that we're interested in, and it usually will say less than, greater than, shorter than, taller than, wider than, narrower than. This time it says less than, so looks like we're using a less than symbol. Okay. So next step, we have to find the significance level. Well, I already wrote that down up here, so I'm just going to copy it down. Alpha equals 0.05. After you find the significance level, we have to find the confidence level. Anyone remember the formula? 100 times 1 minus alpha. Perfect. So if you ever forget where that formula is, I wrote it down in the list of stuff to do right under here, under step 3. Okay, just plugging in 0.05 is alpha. So in my calculator, I'll just subtract 1 minus 0.05 first. I think that's 0.95. I'm not good at math, but at least I can do that in my head. And then when you multiply that by 100, we get 95% as our confidence level. Okay. Any questions on what to do here? Cool. All right. So what I'm going to do is just going to show you what you click on Minitab. It's very similar to what we did before. So let me just kind of go over this real quick. Okay. Also, if you're doing the homework and you're asking Hannah about Minitab, I don't know if Hannah, you didn't learn this in your class, did you?
We did like Minitab labs, so we learned some of it. But
Yeah,
like,
but
it wasn't like, the basis of it.
Okay.
I'm sure.
I'm sure Hannah will figure it out, but give Hannah some grace. If she can't figure it out, then don't yell at her. Just yell at me. Okay. All right. So what you're going to do, you're going to click Stat, Basic Statistics, and we already talked about one sample Z on Wednesday, but we're going to click on one sample T. Okay. So if you ever forget what to click, it's on that list of steps to do on the back of the first page. Now, when you look at this, it kind of looks confusing because it doesn't tell you what to type in. Just change the drop-down bar to summarize data, And then it will tell you like all the different stuff to type in. You can either look at the list of stuff to type in, or you can just read what Minitab's telling us to do. Minitab says, gosh, to type in the sample size. Well, we said that was 100. Okay. Sample mean, I wrote that down in the beginning. That was 703. We talked about the standard deviation. I wrote that down as 92. Okay. We're doing a hypothesis test, so I guess it makes sense to click the box for perform hypothesis test, right? Under hypothesized mean, we're just going to write down whatever the the null and alternate hypothesis numbers are. So if you take a look at step 2, we said that the mean was equal to 720. Okay, I wrote that one down, 720. Okay, and at this point, it's really tempting to just click OK and go on. But we didn't tell Minitab if it's less than, greater than, not equal to yet. So click on options. Okay, change the confidence level to whatever we calculated. It was 95 this time. And under alternative hypothesis, under the drop-down menu, there's 3 options: less than, not equal to, or greater than. Looks like we're doing less than because that's what we said in our alternate hypothesis, right? So we're just telling Minitab what we said in the beginning. Now we can click OK and OK again. And what we get is a lot of information. I kind of ignore this first part unless I'm doing a confidence interval question. But then at the very end, it tells us what the test is. It tells us what the non-alternate hypothesis is. And right here, we've got the p-value. So this is literally the same thing as we did on Wednesday, except we're just clicking a different button in the beginning. Everything else is the same. Okay. Any questions on what to click on the Minitab? Okay. I know some teachers teach this by hand. I think doing Minitab is so much easier. You just click a button and type in your information and it just pops out the answer to you. I don't know. I find that a lot easier than doing anything by hand. Okay. All righty. Gotta get my iPad back on here. 3, 2, 1. There we go. All right, so if you flip to the next page, well, I copied and pasted what Minitab spits out at you. Well, the p-value is really easy. It just says p-value 0.034. That was pretty easy. So that's how we know what our p-value is. Okay, next we have to decide if we reject the null hypothesis or if we fail to reject the null hypothesis. Does anyone remember how to do that?
If that is bigger than the alpha value or 0.05, then you accept it, but if it's smaller.
Yes, sorry, that took me a while to process. Okay, so what Noah said is we're going to compare P and alpha, right? I like writing them side by side. If I don't write them side by side, my brain does not work and I cannot figure out which one is bigger. P is 0.034. Alpha is, we write that down, 0.05. Now that they're side by side, it's easier for me to tell which one's smaller. Which one is smaller here, P or alpha? P is definitely smaller. And as Noah said, if P is smaller than alpha, we actually reject the null hypothesis, right? So we reject the null hypothesis here. If P was bigger than alpha, we would fail to reject the null hypothesis. Okay, so we know our conclusion. All we have to do is interpret it in words. We do that by combining 2 parts of a sentence, right? If we reject the null hypothesis, what do we start with? We conclude or not enough evidence? We conclude, good. Okay, and this is because we reject the null hypothesis, okay? And what is always the ending to the sentence? Mu is bigger than, less than the alternate hypothesis, right? So since the alternate hypothesis says less than 720, well, mu is less than 720. Okay. Now it's very important to phrase it in the right way. That's why I like the template. You're just piecing together 2 parts of a sentence, and then you get your conclusion. Okay. Any questions on how to do these problems? All righty. If you flip to the next page, we have example number 2, very similar. Why don't I give you some time to work on this? I might not give you enough time to finish it, but I'm going to give you a little bit of time to work. Why don't we come back up front here? I kind of want to start going over this because we do have to take a quiz at the end of class. Here we're looking at TV watch times. whenever we started this question, I think I got Ange to write up all the information. She did a really good job of picking through the paragraph, making sure everything is written down here. I didn't see it as I was walking around today, but my last class, I saw this mistake a lot. A lot of people mix up the sample mean and the population mean here. And it is kind of confusing when you're looking at a question, trying to figure out if 3.09 is the population versus the sample mean. Does anyone want to explain why 3.09 is the sample mean and not the population mean?
It was given along with the sample standard deviation, which is nice.
Oh, that's true. Yeah, it's given with the sample standard deviation, right? So that would make sense. And it's also like mentioned right after we talked about the sample, right? So we introduced the sample immediately after we talked about the mean. That means that the sample mean has to be 3.09. I do think that this question was written a little bit more confusing than I would normally word a question. But I do think it is kind of obvious that 3.09 should be the sample mean and not the population mean. Okay. Any questions on what the symbols mean? Nice job, Ange, on that. Step 1 was stating our assumptions. I think I got, was it Hayden to write this one up? Yep, Hayden did a great job. Sample size bigger than 30, sample standard deviations given. That's all you have to do on that one. Okay. Step number 2, writing the null and alternate hypotheses. I got Kate to write this one up. She did a great job here. She said that the null hypothesis was equal to 3 because it's right here. The alternate hypothesis, she said, was not equal to 3 because, well, take a look at the last sentence of the question. Is there sufficient evidence to disprove the claim? That's not greater than, smaller than, taller than, shorter than, anything like that. It just says, is there enough evidence to say that something's different, right? So if there's nothing that says taller than, shorter than, wider than, narrow, and then not equal to is the symbol that you're using. Okay. Step 3 was writing, I didn't get Kate to write this one. Who wrote up step 2? I'm forgetting who writes up everything. I don't even know. Whoever wrote up step 2, good job. Okay, Kate wrote up step number 3. This was, I noticed your handwriting, Kate. I was like, okay, this one looks more like yours. The significance level, right? Kate did a good job of calculating the confidence level by just using the formula, plugging it in. You should have gotten 99. Okay. Is everyone good having me skip showing you what to click on Minitab? I think everyone, Minitab's pretty self-explanatory. You just click the button and you fill in the chart. I think that's pretty self-explanatory. Once you go to Minitab, p-value 0.259, pretty easy to spot. It's literally labeled on Minitab. And then, well, we have to decide if we reject or fail to reject. We do that by writing p and alpha next to each other. P is 0.259. The question gives us what alpha is, 0.01. I think it's pretty obvious that p is a lot bigger than alpha, right? So if p is bigger, do we reject or fail to reject? Fail to reject, good. So fail to reject here, okay. And if we fail to reject, do we start with we conclude or not enough evidence? Not enough evidence, good. This is probably good for your quiz. There is not enough evidence to conclude. I don't know why I wrote enough like that. That. And then you end with the null or alternate hypothesis. Alternate, it's always the alternate hypothesis that goes at the end. The alternate hypothesis said mu is not equal to 3. So we write mu is not equal to 3. Okay. Any questions on how I did this problem? I think we're all experts on how to use the one sample t-test. Next class, we'll start with actually deciding like which test to use. I think that's a good skill to work on, but I do think we have a quiz.